Let's talk about where the graph increases, decreases, and stays constant. In other words, we're going to talk about intervals of increase, decrease, and where the graph is constant. We write these intervals in interval notation. The biggest thing that I see students do is they try and write coordinate points where the intervals start and stop, but these are not coordinate points, they're intervals. So you only use the x values. From this x value to this x value is where the graph is increasing. They look like coordinates because we're only going to use parentheses, no brackets here. Put a U or a comma between your intervals if there's more than one. And where one interval ends, the next one should begin. So you shouldn't have one interval stop at 2 and the next one pick up at 2.5 unless there is a physical horizontal gap in your graph. Let's do some examples because I think it's fairly straightforward as long as you remember to only use the x values. So look at this graph. We read it from left to right, and let's talk about where it's increasing, decreasing, and constant. It helps me to actually label the graph. So from left to right, think of this as a roller coaster. I would be increasing here, then I reach the top, and I decrease to go back down. I'll come back up and increase again, and then finally I decrease. I don't care about these y values here whatsoever, so ignore that the y-axis even exists. You only care about the x-axis to tell you where the intervals are. These graphs have arrows, so that means we are implying that we are starting from the negative infinity and going all the way to positive infinity. All right, so our first interval here is this portion of the graph. We are increasing, and that is from negative infinity to x equals -3. Only use x values. Then we start decreasing in this section of the graph. So from x equals -3 to x equals -1. Next, we're increasing right here. So that is from x equals -1 to x equals 2. Notice where this decreasing interval stopped is where I picked up the next increasing interval. And then finally, we decrease for the whole entire rest of the graph. So from x equals 2 to x equals infinity, because this is an arrow here. It is pointing down, but we're using x values, so it's pointing to the positive infinity side of the graph. The graph never flattens out anywhere, so there is no constant interval. One thing I want to point out is we're using parentheses here at all of our intervals because check out what's happening here at x equals -3. At x equals -3, we're not increasing anymore and we're not decreasing anymore. We've reached the peak, the tipping point, and we're about to go back down. So because we're not actually increasing at -3 or decreasing at -3, we're changing direction. We use parentheses. You use parentheses when you're not actually hitting that specific point. All right, let's start this graph, figuring this out by labeling where it's increasing and decreasing on my graph. Kind of think of it as a roller coaster or like the horizon line. Where's it going down? Where is it flat? Where is it going up? And where is it going back down? Okay, we're going to start talking about, because we read from left to right, we're going to start with this decreasing section. There's not an arrow here, so it specifically starts at x equals -4, and it stops decreasing. I'm going to round to x equals -2. All right, wherever it stopped decreasing at -2 is where it picks up being constant. So from -2 to 0 is where it's constant. And again, I stopped being constant at 0, so that's where I increase from 0 all the way to x equals 4. And finally, from x equals 4 onto the rest of the graph. So this is the positive infinity side of the graph because we're on the right side of the graph is where I'm decreasing. I want to point this out again. I tried to say it while I was writing my intervals, but it may not have been clear. You could have used 1/2 here instead of 0, where I just drew my arrows, because it does kind of look like it's more closer to 1/2 where it starts going up again. I don't care if you round to the half or if you use whole numbers, just make sure whatever number you put where it's constant is also where it starts increasing. Just like before, I am going to label my graph where it's decreasing, where it's increasing, and where it's flat. All right, we have a definite endpoint at -3. So from -3 to -2, we're decreasing. Then we increase. Then we decrease again. We're flat, which means we're constant. And we increase. Two things I want to point out: where one interval ends, the next one starts, and we put a U or a comma between our intervals. The last one ends at infinity because there's an arrow there. Example 4, I'm going to start by labeling my graph again. The left side of my graph has an arrow, that's the negative infinity side. So from negative infinity to x equals -2, I'm increasing. From -2 to x equals -1, I decrease. From -1 to 0, I'm flat. And from 0 to 1, I'm increasing. From 1 to 3, I'm decreasing. There's a definite endpoint at 3. Last example, I am going to label it again where it's constant, decreasing, and increasing. You read from left to right, so we start on that definite endpoint of -4. We are flat from x equals -4 to x equals -1, and then where that ends at -1 is where we start decreasing. And then we increase, decrease, increase. Notice that wherever one interval ends, the next one starts, and then we increase till positive infinity because we are on the positive infinity side of the graph.